All right, little video here about the difference between these two concepts, probability of A and B versus the probability of A given B. Now, if you can understand the difference between these, the games and big decisions and all of the lecture content that involves Bayes' theorem is going to make a lot more sense. Now, this concept made me scratch my noodle a bit when I first started getting into learning about probability. So I just want to share with you how I made it clearer for myself. So this diagram represents a universe where events of type A can happen and events of type B can happen. And you get events that are of both type A and B that happen in this little overlap here. And events that are neither A nor B happen, outside this. But everything happens within the universe U. Everything is a type of the type U. Every event is of the type U. Cool. So in previous videos, I've talked about how to work out the probability of A happening. We just get the area of A and divide it by the probability of the universe of possibilities. So which gives us the percentage in terms of area that A is of U. So if our area of U is 1, I've written the area of A as 0.6, the probability of A is simply the area of A over the area of U. And of course, because the area of U is 1, that's just, divide a number by 1, you get that number back. Cool. So probability of A is 0.6, probability of B is 0.2. So what is the probability of A and B? Well, it's just the area of the overlap. No surprises there. But what is the probability of A given B? Now, the tricky thing is, and the reason why I think this is confusing, is that the area of this is also this overlap here, and that's confusing because they're not actually the same probabilities. Something I should write here is that P of A and B does not equal P of A given B. Let me get that a bit straighter. They don't equal each other. And why is that? Well, that's because when we say given B, we're restricting our universe of possibilities down to B. We're saying that B has happened or it will happen. It's a given, all right? So to work this out, we consider the events we're interested in, work out what area they take up. So again, it's this overlap, and we divide by the realm of possibilities, and it gives us the proportion of our possibilities that is made up of by the events that we're interested in. Now, hopefully that word salad made a little bit of sense, but I'm just gonna, hopefully writing out the equation will help. Probability of A given B. So what is that? Well, when we say given B, we're shrinking down the universe of possibilities to B. We're saying B has happened, whatever happens has to be inside B. So what's the probability of A happening? Well, it's still involves this little overlap here, but it's within the context of B. So how do we work out the probability of A given B? Well, we try and work out what percentage of B is made up of by this overlap. And to do that, we get the area of B, area of that overlap, and we divide it by the area of B. And that gives us 0.4, which is 40%. Now, why is this confusing? I think that working out understanding the difference between these two is tricky because in a 2D representation like this one here, both these probabilities are represented by this overlap area. The only difference is in the second one, the context of other possibilities is restricted. Instead of being the whole universe, it is B. It's shrunken down to this. So just to drive home the point, let's work out what the probability of B given A is. Well, that's simply, again, it's the area of the overlap here, divided by our restricted context, our given context, the universe of possibilities, which in this case is A instead of B. So instead of dividing by the area of B, we divide by the area of A. I'm going to need to get the calculator out for that one. .08 divided by 0.6, which is 0.1333. Cool, which is like 13.33%. Great.